All right, we're going to start with our first example, recognize solutions of quadratic equations. And our question is, why are the x-intercepts of the graph of a quadratic function important to the solution of a related equation? So part A, find the solutions of the quadratic equation x squared minus 16 equals 0. So you can see we have a graph that we're going to fill in. So our first step is we are going to graph the related function. F of x equals x squared minus 16. So we have our quadratic equation. Here's our quadratic expression on one side, 0 on the other side. One way to find solutions is to look at the graph. So we just look at the related function. So to graph this, well, we worked on that in our last unit. This is vertex form, so we can find the vertex. If you notice, we don't have any movement of our x's, so our x is 0, but we have this minus 16 on the end of our function, so 0, negative 16 is our vertex. And then we just need our graphing pattern. Our a value is equal to 1, so our pattern is just a 1, 3, 5. So I'm going to zoom in and we're going to plot our vertex, and then we're going to do our graphing pattern. So our vertex is at 0, negative 16. Now our graphing pattern, up 1 to the right 1, up 3 to the right 1, and up 5 to the right 1. Let's get those points reflected on the other side of our axis of symmetry. Now, because we are trying to relate the x-intercepts, how does that relate to the solution of the equation? We actually want more points on our parabola. So 1, 3, 5. Let's go. The next one, and we haven't seen this yet, would be a 7. So if you go through your 1, 3, 5 pattern and you have room to plot more points, now we could go up 7 over 1. So let's take a look at that function. If we go from our last points, up 7 to the right 1, and then get that reflected point on the other side, that's going to give us enough points to talk about right here. So first step is we graph the related function. There's our lovely parabola. Next, we are going to identify the x-intercepts. That's why we continued our graphing pattern with a 7, because we did want to see the x-intercepts. We have 2 of them. There's one right here, and there's one right here. So those x-intercepts are negative 4, 0, and positive 4, 0. So what that tells us is a couple things. The solutions to the quadratic equation that word is quadratic. It doesn't quite look like it. Are those x-intercepts, x equals negative 4 and x equals positive 4. Now, if we think about that, does that actually make sense? Well, remember our equation was x squared minus 16 equals 0. So if we plug in a negative 4, just to check, negative 4 squared minus 16 equals 0. If you square a negative 4, you get 16 minus 16, and see how we get 0 equals 0. So our first solution of x equals negative 4 worked out. Well, what happens if we plug in a positive 4? 4 squared minus 16 equals 0. Well, 4 squared is 16. And we can see that we are finding 2 different numbers that work out in our equation. So we do have 2 solutions. And then visually, those solutions are going to be the x-intercepts if we graph that related function. So one last thing to add on here. x equals 4, or let's see, no, 4 and negative 4, those solutions are the zeros of the function. So that's a vocab word from our learning target video. Those are going to be the zeros of the function are the x values that make our function f of x equal to 0. Okay, so that's how this is going to work. We are going to graph our function, look for the x-intercepts. Those x-intercepts will be the solutions of the equation. This part right here, we don't have to show the check every time, but I just wanted to show you that there are, in fact, two different numbers that are solutions to the equation. All right, so part B, let's try another one. There we go. Okay, so what do we do first? We're going to graph that related function. So f of x equals x squared minus 14x plus 49. All right, so in order to graph that, we want the vertex in our graphing pattern. So the vertex, we find this is standard form, so it's a little bit more work. We're going to do our x equals negative b over 2a. So we have a negative, our b value is a negative 14 over 2 times our a is 1. So this gives us positive 14 over 2, which is 7. So we have half of our vertex. Now to find the other half, we're just going to plug in. Let's figure out what is f of 7 if we plug that into our function. So I'm going to replace all the x's with a 7. I'm going to grab my calculator, type it in exactly as I wrote it with those parentheses and everything, and we get back a 0. So that means that the other half of our vertex was a 0. Our a value is equal to 1, so that means we have a 1, 3, 5 graphing pattern. All right, so if we go to our graph, we said that the vertex was at 7, 0, so I'm going to go over 7, up 0, plot that point. Our graphing pattern is 1, 3, 5, so up 1 to the right 1, up 3 to the right 1, and up 5, 1, 2, 3, 4, 5 to the right 1. Let's get those reflected points on the other side of the axis of symmetry. We can sketch in our parabola. And then we want to identify any x-intercepts. We have an x-intercept at 7, 0. So that means that our solution to the quadratic equation is x equals 7. All right, let's try one more. Find the solutions of x squared plus 4x plus 7 equals 0. So we're going to follow those exact same steps. We're going to start by graphing the function. And they call this the related function. So we're taking our equation and we're going to graph the quadratic expression of that. So f of x equals x squared plus 4x plus 7. That is in standard form. So we're going to find our vertex first. X equals negative b over 2a. So negative, our b is 4 over 2 times our a is 1. So that's a negative 4 over 2, which is negative 2. So we have half of our vertex. To get the other half, let's figure out what f of negative 2 is. Just plug a negative 2 in for all your x's. You do have to use parentheses around this negative 2. Otherwise, we will get the wrong answer with our calculator. So when we plug that in, we get a positive 3. So there's the rest of our vertex. Our a value is 1, so we can use a 1, 3, 5 pattern. Now we go down to our graph, and we're going to start by plotting the vertex at negative 2, 3. And then our a value gave us that 1, 3, 5 pattern. So up 1 to the right 1, up 3 to the right 1, up 5 to the right 1, and then let's get the reflected points. We can sketch in our parabola. And now we can look at our graph to identify any solutions. So those solutions are going to be any x-intercepts. So if we look, we can see that this vertex is above the x-axis and it's opening up, so it's never going to cross the x-axis. So it is very possible that you will not have any x-intercepts. So what does that mean for your solutions? It means there are no solutions. And what we say is that there are no real solutions, because we do want to remind ourselves that we're talking about real numbers. We're in the real number system. So we have no real solutions for this quadratic equation.